All right. So welcome back to Solar Power Pro certification. We're going to have a bunch of fun information today. You guys are going to be learning all the definitions for solar. We're going to be giving some examples to go along with those definitions. And then we're going to go over the overview. And then tomorrow we're going to pick it back up with the storage, but this module is going to cover these main core functions. There's a lot of little mini modules inside of this where we're talking a lot about the actual definition, what it means, how it works, and how to apply it to solar. So that's what we'll be doing. First thing we got to learn a little bit about is electricity. Okay, so what is electricity and how does it work, right? So here's the deal. When you get your home energy bill, when you guys get your electric bills, it lists usage in kilowatt hours. When you go to the store, you see things like 12-watt light bulb, 9-volt batteries, and vacuum cleaners have like 15 amps of sucking power, right? So what do all these numbers mean? Well, it all means that they need a specific number, whether it's going to be the wattage, whether it's going to be the amps, in order to be able to create the energy that it needs in order to be able to run. Okay. So all these things have to function together in the very end. So there's several important things that need to happen in an electrical circuit to make the electricity flow for the work to be done. So it looks like this. You can think of a circuit kind of like the faucet in your kitchen sink. If you want the water to come out, you need two things. You need the water itself, you need the pressure to force it through the pipes out of the faucet, right? So you need those two major things. An electrical circuit uses electrons to carry the electricity, kind of like the water in your faucet does, but those electrons need something to push them along. So that comes to our first definition. Now you guys are going to be tested. You're not going to be tested on a lot of this part of it. This will just get you some general understanding. Good foundational work. Okay. First definition is going to be voltage. So it's a force associated with electric current that is measured in units known as volts. Power companies use high voltage to move electric power over long distances. This electrical pressure is what we call voltage and is often provided by two terminals, which are a positive charge and one with a negative charge. I wonder, where have we seen something like that before? Oh, great question. A battery, right? We've all seen a battery before. We're all familiar with kind of how this stuff looks, right? So what do we have to worry about? Well, what is the voltage, right? This is how it goes. So if we just go back to what we were originally learning a second ago, utility companies use high pressure. They use high voltage, which is high pressure electricity to push it all the way from the grid where it's being powered to your house. So let's learn that. Here's the simplified definition. Voltage equals pressure. Voltage equals pressure. Electrons flow from the negative through whatever you're trying to power and then into the positive end where they'll stay unless the battery is rechargeable. Okay. So that's simple enough. Electrons are going to flow from the negative end. So right here at the bottom where the negative is, through, let's say, the remote, and then they store here unless the battery is rechargeable, and then the battery dies once there's no more power electrons here, right? If you're plugging something into the wall, the voltage is instead provided by the power company. Although voltage just measures how strong the electricity is being pushed through a circuit, it's important because how many circuits are designed only to accept a certain number of volts, okay? So again, it's not something you're going to be heavily tested on, if at all. Laying the groundwork. So what are amps? Amp is short for ampere, okay? It's a unit of electrical charge is flowing past, it's a unit of how much electrical charge is flowing past a given point in 1 second. So if you put volts and amps together, you can tell how much current is flowing and how hard it's flowing. Why is that important? Because we need to get out the power in the end of it. We need to figure out what the wattage is. So in order to be able to find out the wattage, we have to use, so amp equals flow. We're going to have to use a power formula. So P equals watts, the I equals the amps times the volts. So we use volts times amps in order to get the wattage. In 2 seconds, got a rep text in. Yeah, new reps needs a little bit of help. All right. So when you put volts and amps together, so volts times amp equals the actual wattage, we can tell how much current is flowing through and how fast it's flowing. So let's take a look at this example. Let's suppose you hooked up a water wheel to a generator. You're trying to get that water wheel to spin so that you can create energy with the generator, right? Well, if you use a water gun, it's going to force water through the small nozzle, which means the total volume flowing per second is not very much. Not a lot of water is going to fit in that small nozzle, but it creates a lot of high pressure, and it's going to push it out at a high stream, at a very strong stream, and it's going to get the wheel to turn, right? So now let's replace the really small nozzle with high pressure to a garden hose, which is a lot wider of a nozzle, right? So even though the wide hose doesn't push the water out as strong, more water flows every second, ends up spinning the wheel at the same speed. So what does this mean for electricity? Well, it means they're creating the same wattage. That's the important part. Okay. So if we're thinking the hose and the water gun pushing electricity instead of water, we could say it's delivering the same number of watts, which is what we're going to be dealing with solar. So here's an example. We just need to figure out the wattage, right? So let's say you're going on a trip and you have a gaming computer. It looks something like this. So let's say you have an 1100 watt power supply at full load on our outlets out here in North America. Well, it's a 110 volt outlet. Okay. Well, we need to figure out if it's going to work over there. So you get the number of watts and you divide it by the volts. So just reversing the formula, and you get the number of amps. It's going to push out. So we're going to have 10 amps of electricity. Well, what about 220 volt out there in Europe? Well, 1100 divided by 220 is going to equal 5 amps. Now, even though the amps and the volts are different, because the watts are the same, the computer will still work the same in both places. Okay. So if we go back and we think to the original question, why does a vacuum need 15 amps of sucking power? Right. Well, it needs that draw. It needs a more amperage. So the wattage in the end likely won't be the same. Right. You guys have probably heard the term before. You burn more gas by starting your car than you do by keeping it running. Right. So ACs, large appliances like that, like ACs, vacuum cleaners, washers and dryers, they require a large load, a large amp draw in order to be able to start, and then it uses a consistency to keep it running, okay? Now, if we're just looking to keep it running and we just need the wattage, this is gonna be perfect. So this part might be in your test. What is voltage? Well, voltage is measured in V's, volts, and is the pressure. Current is the diameter of the hose, basically, right? The wider it is, the more water will flow through. This it's measured in amps. You usually see that in I or A. We didn't go over this one much because we're going to do it more later in the module. Resistance. It's like kicking at the hose or putting sand inside of a hose or something like that. It's going to restrict the flow of water. So it's usually measured in ohms. So this is the resistance. Okay. The most you'll be tested on will be something like maybe, I don't know, what's voltage equal? Pressure. What's current equal? It's the amps, it's the flow, right? What's resistance? Ohms. So I don't want you guys to have to worry too much about the other stuff. You're not going to be doing those type of calculations. We do them. It's going to be a bunch of stuff you guys never have to talk to a customer about. I don't say never. but 99 times out of 100, you won't. Okay. Most people just don't care. You want to know how it works, not that it works, or that it works, not how it works. Okay. So what are kilowatt hours? Well, is it a unit of time? Let's let everybody take a quick guess on that. Yes or no? There are no wrong answers because you haven't been taught yet. Ooh, nobody wants to take a stab. It's not. It's not a unit of time. You know what it is? It's a unit of energy. Okay. Now, watts and kilowatts express how much energy is consumed per chunk of time. This is called power. It's not the same as energy. Utility companies charging kilowatt hours. Kilowatt hours and kilowatts are completely different things. The customer's system size is based off of kilowatts, based on the number of kilowatt hours the customer needs a system to produce. Kilowatts are not the same as watts. To get the number of kilowatts, you simply divide the number by 1,000 or simply multiply the number of kilowatts by 1,000 to get the number of watts. Okay, so here's an example. 8,000 watts equals 8 kilowatts. 9.7 kilowatts equals 9,700 watts. So we're just moving the decimal, right? We have three zeros, we move the decimal. Now, kilowatt is the size of the system. Kilowatt hour is energy that it produces. So we're going to be dealing with these two numbers. Okay, on the back end, we deal with the voltage and the amperage and all that other stuff. Okay, so for your guys' sake, this is going to be a very important definition for you guys. Kilowatts is the size of the system. Kilowatt hours is the actual energy it produces. So a kilowatt is a measurement of time, or sorry, a measurement of power, while the kilowatt hour is the length of time that something can use a kilowatt. 1 kilowatt hour is equal to 1,000 watts sustained for 1 hour. PV solar systems size is calculated in kilowatts. The size of the system is determined by how many kilowatt hours is needed to be produced. This is what we're trying to accomplish. We need to know how many kilowatt hours a customer has so we can build a system in kilowatts. Now, a PV system generates power from the panels, converts it from DC to AC at the inverter, and then use that to power the home. The excess power generated is sold back to the grid in the form of bill credit. The system stops working when the grid is down. So this is important. Solar-only systems. Solar-only systems do not operate, they do not function when the grid is down. This is for, and we have this written down in more detail on another slide, but what's important to understand about it is that it has to be shut down so it doesn't transfer power back to the grid for the safety of first responders, as well as power line workers and firefighters and all that other great stuff. Okay. So if you have a solar-only system, I don't say this because it's not true. If you've heard the term before, trickle power, that doesn't exist. I can't believe I have to say that nowadays. There's no such thing as trickle power. Okay. If the grid goes down, there is no more power going to the panels or from the panels. Okay. Now, that's for solar-only systems. As far as the inverter, that converts it from direct current or DC to alternating current, AC. Or as we like to call it, sun power to house power. That's it for this part of the first part of the module. What questions we got?
So far, so good.
Awesome. Cool. Let's do this.
I have more of a comment.
Yeah.
Just from my experience, being able to have a homeowner understand the difference between a kilowatt and a kilowatt hour, that's really the key, because you're bridging their world of their electricity in their home and connecting it with the electricity they can get from the solar panels when they understand it. So I would just say, yeah, master those two things because that allows you to make that bridge and also do a proper bill review. And yeah, that's all I have for now.
Oh, that's perfect. That's exactly right. That's why I teach you guys that, and I have those definitions there for that exact same reason. Other companies are not going to take the time to talk to the customer and let them know, like, hey, guess what? They're not the exact same, right? Can't tell you how many times I got an 18,000 or 18,000 kilowatt hour or kilowatt system.
Right.
18,000 kilowatt. Hold on. Let's break this down. How many panels you got? Oh, I got like 40. It's not. Hold on. Let's go back, right? Like a lot of stuff you guys are going to learn today, 99% of sales reps have no idea what it is. Okay. Your brains will feel like it's overloaded. When we go through the examples of the bill review, when we go through the examples of proposal, you'll see how we fit these in so you guys can properly explain it and realize, oh yeah, I actually know a lot more than I originally thought. Okay. So yeah, cool. Thanks, Joe. First thing specific about solar that we're going to learn about in building systems is called azimuth. This is for your guys' information. There's ways that you guys will actually explain to the customer. I'm going to give you a couple brief examples of how we explain to the customer, but you're going to see it live when we do this again on Thursday and Friday. Okay, so azimuth is a good one to learn. So here's a very complicated definition. I'm going to make it simpler. Azimuth is the direction of the solar panels from the observer, expressed as a singular distance from north or south point of the horizon to the point at which the vertical line passing through an object intersects with the horizon. So this would be the center for the observer. We have 0, 90, 180, 270. Then we have the points in between. This looks kind of familiar, right? It's a compass. That's all it is. Okay, so we're going to look at the north, south, east, and west, and every point in between. That's how we're going to determine the actual azimuth. So don't worry about this very long, boring one, right? Simpler, it's a compass. 0 degrees, 45 degrees, 90 degrees, 135, 180, 225, 270, 315, and every point in between. Just like a circle, north, east, south, and west, and all the points in between there. So how does this work? Well, if we're looking at a roof, okay, so if you open up your maps right now, you're actually looking at north, south, east, and west the second your map's open. You're always going to be looking at the north point at the very top of your phone. So what does this mean for solar? It's the direction of the panels, which directly impact the production of the panels. That might be under test. So does the direction of the panels impact the production? Yes, 100% it does. Okay. So let's do something like this. If we have this roof, we're going to have a bunch of different azimuths. So this is north, south, east, west, northeast, southeast, right? So this roof slopes down this way. So the panels will be facing this way. So that's 190 or 180. This would be 90 because it's facing east. This is facing east. It's 90. These are facing west. It's 270. You guys starting to see the picture here? This is kind of what it looks like for you guys when you're looking at a roof. So anything north is not a good point. We don't like going north unless we were going to be south of the equator. Okay. So we want to be 180 is the optimal or due south for solar, because from sun up to sundown, you're going to get the most direct sunlight on those panels throughout the day. So from sunlight to sundown, you're going to get it, which is going to produce the from sunrise to sunset, the solar panels will receive the optimal amount of sunlight to produce the required kilowatt hours. This may vary depending on the consumer needs. So it can be a factor with a lot of different stuff. So let's look at this. When mixing multiple azimuths, the factor changes and requires a higher kilowatt system to produce the same amount of electricity or same amount of kilowatt hours. What do we mean by this? Well, we have a bunch of different roof planes here, right? We're gonna talk more about flat roofs and stuff here in a little bit, and why we love them so much. But if we take a look at this, we got a bunch of 180s, we got a bunch of 270s and 90s and zeros and all that good stuff in between. And we have this flat roof right there. If we have to mix these, it's going to be a mixed array. We have multiple arrays on this system. So this one's going to be facing east or 90 degrees. This one would be south. And then these guys would be 270. Why I like this one is because we could determine based off of our tilt, which we'll learn after this, we have room on a flat roof. It's pretty cool. So I'll show you guys more about flat roofs and how we do those in the next part of the module. But this would be considered a mixed array. This would be multiple azimuths on one house, which reduces the actual factor itself, which means that you need more panels to produce the same amount of kilowatt hours. So these are going to produce more sunlight from sun up to sundown than these two would, because halfway throughout the day, they're not getting direct sunlight. That's what's important to understand about it. Okay. So simply, before we get into tilt and all the geographic stuff, does the type of roof start affecting it? Absolutely. Because we can't cut back a roof in order to change it, right? So let's take a look at real life scenarios down here in Southern Arizona. So this is actually down in Mesa. It's true satellite image. It's determined a couple of these azimuths so we can take a look at them. So let's take a look at this house right over here. First, we got to pull up our compass. So remember what we're looking at. And I want to get a 275 and a 95 is basically what this one would be. Okay. I don't see any south facing roofs. Got a small little sliver back there. If we were closer, we could probably see if it'd be usable. But the majority of the roof space is going to be 275 to 295. Well, over here, we have a 225. It's a little bit too north facing for our liking. So if we can avoid going on that roof, we're going to. We'll put most of them right here at the 225. Well, what about this one right over here? This is 170. Okay. This one is facing just slightly southeast instead of south, directly south. Right? Why is this important for you guys as salespeople to understand? The way that you would explain it to a customer is simple. So let's say that you have Mary over here, okay? And you have Bob right here. Mary bought solar from you like 6 months ago, was talking to Bob about it, and she loves her system. She has an 8 kilowatt system. She's going to be producing 14,000 kilowatt hours a year. Bob also needs 14,000 kilowatt hours. They have the exact same bill, which doesn't really happen, but let's say in this case it does. And he needs let's say an 8.7 kilowatt system. So an extra panel or two. 8.7 kilowatt system to produce the same amount of kilowatt hours that the customer that she needs over here. He needs 14,000, but over here he needs an 8.7 kilowatt system rather than just an 8. About 2 more panels. Whoa, whoa, whoa. Why is my system larger? It's a great question, Mr. Customer. So right here at Mary's house, from sun to sundown, she's getting optimal position. She's getting optimal position just based off the way her house is built. She's going to get more direct sunlight from sun up to sundown on these panels to create more kilowatt hours than your system. Because just like over here with Uncle Tom, halfway throughout the day, you're going to lose direct sunlight on these panels. So they're not going to be producing at peak. The rest of the day, it's going to be producing peak over here on the west side of the house. You'll still have production, but it drops a little bit because it's not direct sunlight once the sun passes that midpoint throughout the day. Okay. Over here, this guy might need even have a larger system because he only really has that one azimuth he can work on, but he's not getting direct sunlight on the panels until way past halfway throughout the day, right? Well, he might have a problem with it if you didn't know what azimuth was and could properly explain it. Man, all 3 of us use the exact same amount of electricity, but her system is so much smaller than both of ours. Why is that? It's because the direction of the panels directly impact the production. The more direct sunlight that is on the panels, the more production the panels will produce, the more energy they will produce. So you need less equipment to do the same thing that your guys' system would do. Okay. Do we have any questions about that?
Will we have more? Will we have more examples going forward for those?
Yeah, we're gonna have a lot more examples. So we're gonna learn the definitions today, and then you guys will see it when we start going over like proposal stuff on Friday. You'll start seeing it on real houses. Like, hey, this is how it actually looks. This is what it looks like on the house, right?
Perfect.
So we're gonna do that. And even later today, no, sorry, it'll be tomorrow. I have a real proposal on this this pitch deck, or as part of like on their pitch deck. The screens are copy pasted onto here, so I can actually show you guys what they look like, and how you would explain that to a customer. Okay, so azimuth is simple. It is the direction the panels face, and yes, the roof will impact that. but it's just like it is with tilt. Okay, any questions on that one before we move on to tilt? So with tilt, so what is tilt? The tilt of the solar panel is also known as the pitch and will impact the amount of the tilt towards the sun for the PV array. Most arrays are flush mounted, meaning they follow the same pitch as the roof, but are raised a couple inches above. If the roof is flat or nearly flat, it may be desired to tilt the solar panels on the roof to achieve the optimal angle towards the sun. So let's start moving some of that stuff we're talking about with azimuth over to here. So it's going to be the actual angle towards the sun. We're actually going to try to capture as much sunlight as we possibly can. No, this isn't one of our installs. I saw it. I loved it. So I put it in the deck. It's a beautiful yard. And I love what they did with the install. It's absolutely gorgeous. So why is this tilt different on this one, right? So the layout would actually be most effective year round than most other solar installs because it's got different pitches throughout different times of the year. What we're trying to figure out on the back end is the angle of inclination. Okay. So right here, we can see that we've decided that 43 degrees is going to be the best angle for the customers throughout the entire year. Because in December, we need the panels to be tilted at 23 degrees to receive all that direct sunlight. Now, the azimuth is going to have that important factor too to determine how much of that sun is going to be collected based off the angle and off of the position, which way the roof is, or which way they're facing on the roof, right? So we have all these factors that we put into place when we build these proposals. From March and September, we're at like 47 degrees and we'll get all that sunlight. And then at June 21st, when the sun's highest, it's going to be we're looking at a 70 degree all the way up, which puts us at roughly a 43 degree average throughout the year for when we're trying to figure this stuff out. Okay. So depending on the position of the sun and the time of the year, each different tilt will deliver different production, creating a more effective solar installation. What does the customer want to know when they're getting solar panels on the roof? Is it going to look like this? This is what a tilt looks like. We've all probably seen a system or two in our neighborhoods, what happened, that have a tilt like this. It's not a bad thing. It's actually a pretty good thing for the customer. But for an extra panel or two to be a little bit more aesthetically pleasing, we do something a little bit different. We just make sure that we get the right azimuth, we get the right tilt, and we get it flush mounted directly to the roof. If the customer is more about function than they are aesthetics, absolutely, we could drop a couple of those panels and we could tilt it on the actual roof itself. Okay, so these are questions that we'd end up asking the customer. So we'd want it to be completely flush mounted if possible. It's more aesthetically pleasing for the customers. It's better and easier for when they go to sell the house. So a lot of folks like having this style. Okay. Now, are you guys going to have to figure out the angle of inclination? Never. We're going to do that. Are you going to be standing in front of the home trying to figure out the azimuth? No, we're going to do all that stuff for you guys. Okay. So that's how that works right there. Now, this might be on the test. Does location affect the tilt? 100% yes. So geographic location is a major factor. Because the Earth rotates around the sun on a tilted axis, higher latitudes area furthest from the equator will yield lower levels of production. Just like it's possible to get a sunburn on a cloudy day, solar panels can produce energy even from indirect sunlight. So if we think about this, if we can get the right tilt on the panel, we can collect the most sunlight depending on where you are geographically. So when you guys put in the address, it tells the proposal writer, we're going to have to take a look and see what the actual sun factor is and what the peak sunlight hours are in the area, and then where we actually need to tilt those panels, and do we need to increase the actual tilt of those itself. Okay, so they're doing a lot of these things on the back end, but it's just about you having the right notes in the system, like the correct address, the city and state. Okay, so does tilt, is it affected by location? Yep, because we never know, or we don't know until you put the address in, right? There's some really, really cool programs that we use that help us determine all this stuff and shading factors and all that really cool stuff. But what's important for you guys to know is that yes, it does affect it. Okay. It's going to be flush mounted onto the actual roof unless it's got a weird pitch to it. So depending on the part of the country, builder, or personal preference, there are different roof pitches that can work differently, or that will directly affect the solar installation. This will directly impact the tilt of the solar panels. Okay, so 212 is essentially like a flat roof. Most roofs are between 412 and 912. Anything exceeding 912 are steep slope roofs, and we cannot work on those. Okay, 912 and up, we are not going to build on. 812, we can do those. These are like church steeples, things like that, church buildings. We're not going to be working on those. But the rest of these, most new builds are going to be a 612. Older homes are going to be like a 412 on average. We can go in most territories without putting any type of a tilt on a 412. Just a second. So 212 is almost flat. So 212, we'd start looking at having a nice little tilt on those panels. 412 we may, but if the customer doesn't want to put a tilt on a 412 pitch, then we don't have to. All right, but we may need to put an extra panel or two to achieve the same result and kilowatt hours that we need, because we compromise the system a little bit with the actual tilt itself. Okay, so this is how to fix the production. Okay, so adjusting the tilt can compensate for losses based on the geographic location. By adjusting the angle of the panel, the amount of direct sunlight can be controlled. For solar panels to get their best performance, the steep angle of 60 is best. During the spring, the best is at 45, and during the summer, when the sun is at its highest, it's best to have a low tilt of 20 degrees. Because solar panels are mounted to the roof, it's important to determine the best angle prior for year-round production. So there's different factors that we're going to have when we get these utility bills to what we're building the system for. Okay, we're going to look at different times of the year. When are they using most of their power? When do we need to create the most power? Right? So there's a lot of factors that we put in on the back end for these customers to have the correct tilt, the correct azimuth, and to have the system built correctly, so that they know, so you know that's the best system for them, and you guys can relay that to the customer itself. Okay, so you're not going to see panels like this. This was a test photo from REC, and I liked it because you guys can see there's a lot of difference. So this would be like a 412, 612, 812, and it goes all the way straight up, right? But we can make those adjustments on the roof if we need to. So why we love flat roofs. So let's take a look at some of these fixed mounts. So just so you guys understand the difference. So the first thing that we want to talk about is called the fixed mount. A fixed mount is when you see the panels affixed to the actual roof itself. It's going to be flat and flush up against the actual roof. So just like we were looking at that last demonstration. And all the panels are going to be looking like they're one giant unit. This is what a fixed mount looks like. The other one's going to be an open mount. Okay. And we use those on flat roof systems. We love flat roof systems. They're super, super simple to install on. There's always an adder, so we need to make sure that we have that baked in there. So we do that as well for you guys. But if we take a look at here, you can see that there's space in between these, right? So what that means is that we have a nice little gap in between them. Installing solar on a flat roof requires different type of racking and an offset of at least 3 feet by adjusting the panels to the correct tilt. The cool part about a flat roof is that we're not restricted to the azimuth because we're not installing here. The tilt and the azimuth are going to be determined by the roof itself. Flat roof, we can do basically anything that we need to do. We can point the panels this way, we can put them this way, we can tilt them up, we can tilt them back to get the best year-round production. That's why we love flat roof systems so much. It's super simple. Not everyone in the country has a flat roofs as a standard. Down here in Arizona, you see them all over the place. So the largest benefit to a flat roof solar is the system can be installed in virtually any azimuth and any tilt. The solar panels will cast a shadow behind them because of their angle. To avoid creating shade on the rest of the equipment, the correct distance between the panels is necessary. Too close together, and it's going to reduce, it's going to shade each other, and then too far apart, you'll reduce the number of panels that will actually fit on that roof. Okay. So when we're building out the system, it looks a little something like this. When you're looking at an open mount system, You're looking at panels that are being built, just like we saw earlier, and they have that spacing in between it. When you see that spacing, it means that you're going to have an open mount system. They're going to be separated, but they're also going to be at a tilt, and it's usually going on a flat surface. It's going to look just like this. Okay, so you guys will be able to determine that on your proposals, because when you open up your proposal, guess what? This is what it looks like. This is what you see. You're going to see an actual real life satellite image of their house, and you're going to see where we put the panels on the roof. So you know, okay, great. They're here. So I can see that that's sloping 180. And if that question comes up, I can answer it for them. Oh, you have a great roof for solar. From sun up to sundown, you're going to receive optimal sunlight. Oh, we got a flat roof, which is great. So we can make sure that we capture it with the right tilt and the right azimuths. So all it means is the direction of the panels. We can put them whatever direction we need to get the best sunlight. And we can tilt the panels to capture all that direct sunlight because it's on a flat roof. High five for having a great flat roof to install solar on. Okay. That's what an open mount is. So here's an example of the actual shading. So you guys can take a look. These are factors that are being done by the projects managers. We want to make sure that they're spaced perfectly apart so that when the sun hits it and it casts that shadow, it comes up towards the panel, but it doesn't come onto the panel like this guy is shading this part of the panel and he has partial shading. Okay, this is what we're looking to achieve when we do an open mount system on a flat roof. All right. Super quick. Any questions about what we've covered so far? All righty then. Yeah, we're only a half hour in. Making good time. Now, let's go on to the next part. It's one of my favorite ones to talk about. It's shading. Shading is a little bit of a pain in the butt for everybody involved in solar. Okay, why? Because it can cause some issues. So, solar panel shading. Solar panel shading, shading a solar cell is similar to introducing a clog in a pipe of water. The clog in the pipe restricts the flow of water through the entire pipe. Similarly, when the solar cell is shaded, the current through the entire string is reduced. Current equals, it's the flow, it's the amps, right? Now, if only one cell out of the usual 60, and right now we're using 66 cell panels, and one of the panels in your solar array is shaded, the overall output of your system can drop by as much as 30 to 40%. Much like a clogged pipe or kink in your hose, if the current flowing through your solar panel is interrupted by a shaded cell, the end output is throttled. Well, what does that mean? Well, it means that this entire panel right here is now production is dropped by 30 to 40% because it has this little shade up here in the corner, because all these cells are working together. Okay, so if you kink up your hose and you try to walk from one side of the yard to the other, you're going to get a little drip out of the water coming out of the hose, but you're not going to get the full force that you had prior, right? It's the same thing. Why is this important to know? Because it can cause some issues. So partial shading of a cell, one of the main factors that is directly responsible for the degradation of output power is partial shading. Partially shaded cells produce less current than other normal cells exposed to sunlight and behave like a reverse PN junction. As a result, it dissipates power instead of generating it and gets heated. So all 5 of these panels right now, even though it's just a little bit of shading, each panel has dropped efficiency by 30 to 40%. Okay. Now what's happening? What's happening is, has the voltage changed? No. So the pressure hasn't changed. But what ends up happening to the actual current? Well, it's just like kinking that hose up. You have the pressure still pounding away at that cell, but it's not producing what it should. And eventually it's going to start heating up the actual panel itself. It could cause problems for that panel and help degrade it even faster than what it should have been. So when we're building these things out, we're looking at the actual roof like, hey, so we have a roof pipe up here, and that's going to be about 3 feet. So it's going to cast this shadow year round. So we want to make sure we avoid that shadow. So we're trying to do all this. Now, like there's a couple of our guys out in like Waco, Texas. There's a little area where they're working where it's like, hey, if we cut back our trees or we take them down, we lose property value. they have huge trees that literally cover the entire roof. That's a problem for solar because guess what? There's nothing much that we can really do there without cutting down those trees because the panels are going to be shaded throughout the entire year. Will the solar panel catch fire? Likely not. Okay. It's not working like that because the power is not being converted at the panel. And we'll talk more about conversions and a different type of conversions. But it can damage the actual panel, cause it to die out, and it's going to need to be replaced. So an unshaded cell looks just like this. There's no shade on it. It's 100% current and voltage output, partially shaded. Output currently directly proportional to the illuminated cell, no voltage change. So I was talking about. So this cell is shaded. This cell over here is not, but this cell is getting affected by 30 to 40% because this cell is shaded. And over here, there's no possible output on that cell whatsoever. So a shaded solar panel will function or will not function. It's the same as having no sun on a cloudy day or trying to produce solar power at night. It doesn't happen. Okay. Thought I had a video on that, but obviously I don't. And I'll show you guys how that stuff works later because it's super important to understand that. Let me see if I can just pull that video up real quick because I made some new ones this weekend. Oh, never mind. I moved it to the inverter section. Okay, never mind. So that's what it's talking about. Made some adjustments to the proposal this weekend. Shaded cells. Pretty simple stuff, right? Big thing to remember that if one of the cells gets shaded out of the entire panel will drop production by up to 30 to 40%. It's a huge thing to note. Okay. So if you guys see shade on there, or if you see, well, I'm only producing 7,000 kilowatt hours on a 9 kilowatt system, it's because we've already counted the proposal to of what the sun factor would be for shading on that panel. Let's talk a little bit about solar cells. So there's two different types of solar cells. There's monocrystalline solar panels. Each solar PV panel is made up of a single silicon cell. These sometimes referred to as mono solar panels, okay? Polycrystalline solar panels. Each PV cell is made up of multiple silicon fragments that are melded together during the manufacturing process. You may see these called multicrystalline or polycrystalline panels or poly panels. So all solar panels still work the exact same though. The photons are going to be grabbed by the panel. It's going to go through the glass into the actual solid hole conductor, which would be the cell, right? Depending on the type of cell, that's how much output it's going to produce and how much power is going to be created from the actual system itself. So how does this work? Well, first of all, monocrystalline solar panels. Monocrystalline solar panels are characterized by their black PV cells with rounded edges. So monocrystalline panels are black. They have a higher conversion efficiency than polycrystalline panels, which means they produce more kilowatt hours of electricity. If you want to install a solar panel system, but your space is limited, monocrystalline panels will be more productive per square foot. While they're the most efficient solar panels, they're often most expensive since the manufacturing process of a single silicon cell is more complex. Now, they are a lot more expensive. The beauty about us, and I'll show you guys, what we're using and how we're using it. We don't have a lot of these issues with the price on them because of our buying power. Okay. But monocrystalline cells, they're black, right? We're using triple black, but they're black PV cells. If you see blue ones, those are polycrystalline solar cells. Okay. So those panels, they work the exact same way still, but these ones are blue hued. They have straight edges. And they have a lower efficiency compared to monocrystalline panels, which means that you need more panels to reach the same power output. However, polycrystalline panels have a lot lower of a price point since their manufacturing process is simpler. Polycrystalline panels are very durable, but they do tend to last slightly less than monocrystalline panels. They're also affected more by high temperatures, which reduce their productivity on the hottest days. So major differences between them. Efficiency is higher on mono panels. Temperatures are less affected. The panels are less affected by heat on the mono panels. And if you want to look at them at a glance and guess which ones they are, black are going to be mono, blue are going to be poly. I'll show you guys your cheat sheet here in a second so you guys can actually screenshot it. So here's a couple of these key differences. Monocrystalline solar panels have a higher cost when comparing only the panels. The cost of the inverters, the wiring, the electrical, the protections, racking, labor is the same price for both types of panels. Okay. Because monocrystalline panels are more efficient, you may get better return on your investment. And homeowners are eligible for the federal tax credit, whether they choose mono or poly panels, it doesn't matter. So this is super, super, super crucial. I've actually heard this a lot, which is why they're in here. It doesn't matter what type of panels you get, as long as you get solar, that system is eligible for the ITC. They don't have to get poly panels. Some smaller companies have been saying that because it's what they can afford, because they can't afford the same equipment that we're using. Okay, here's your cheat sheet. I'll go ahead and let you screenshot that or write it down. Here are the key differences between them. So monocrystalline solar panels are one silicon cell. So mono means one, poly means many. Polycrystalline solar cells, many silicon fragments melted together. The cost, mono are more expensive, poly are less expensive. Appearance, panels have a black hue, and then poly have a blue hue. Efficiency, they're more efficient. Polycrystalline are less efficient. The lifespan is simple, 25 to 40 years on mono panels, 20 to 35 years on poly panels. And the temperature coefficients, lower temperature coefficient, making them more efficient in the heat. Poly panels have a higher temperature coefficient, making them less efficient in the heat. So does heat reduce the efficiency and lower the production? Yes. Just because it's hotter outside doesn't mean you're going to be getting more solar production. It could actually drop your solar production a little bit because the cells are too hot. Just like your phone. Anybody have their phone kind of brick itself and say, oh, too hot, got to power down? It's the same type of situation. Okay, electricity running too hot is not a good thing. If somebody who works with metal and deals with welders, pretty sure if it gets too hot, turn it off. Okay. So here's what the heat coefficient actually is. Monocrystalline solar panels have a higher heat coefficient. However, it doesn't mean that polycrystalline panels are inferior products. You can find high quality solar panels of both types. Here's a few facts about the efficiency. When solar panels have higher efficiency, it converts larger percentage of the sunlight into electricity. As of 2021, polycrystalline panels have typical efficiencies of below 20%, while the best monocrystalline panels are approaching 23%. What does this mean? Does that mean that the panel is going to be functioning at 23%? No, it's converting, it's actually processing 23% of the sunlight that's available, the direct sunlight. And while the poly panel only converts under 20. Okay. That doesn't mean that's only working at 23%. It's going to be functioning at optimal capacity or optimal production, but only 23% of direct sunlight is going to be captured. That's a good thing on panels. It's actually a really high number. Anything over 20 is considered high in a tier 1 panel. You may need more polycrystalline panels to reach a certain amount of kilowatt hour production per month, since their efficiency is a lot lower. All solar panels suffer temporary efficiency droppages when the temperature increases, but monocrystalline cells are less affected by the heat. The temperature coefficient indicates the solar panels are affected by temperature. All solar panels are factory tested under the same standard test conditions or STC to ensure a fair comparison. In general, polycrystalline solar panels tend to have a higher temperature coefficient, which means that they lose more productivity when they heat up. However, as technology improves, when there are now solar panels of both types with similarly low temperature coefficients. Solar panel efficiency is not a critical factor when there's plenty of space available. Since polycrystalline panels have a lower price, installing more to compensate for the lower efficiency is not a problem. However, when you have limited space, installing more panels is not an option. So monocrystalline panels will maximize electricity production in the available area. Let you screen grab that and write that down for a minute before I move on to the next slide. And I'll explain what that means. Important takeaways. Polycrystalline panels are typically below 20% efficiency, while monocrystalline panels are over 20. Our panels are 21.1. So let's see how this actually works for solar. In solar, the appearance of the solar cells is also a result of their silicon structure, since it determines how they interact with the sunlight and how they are perceived by the human eye. The single cell structure of monocrystalline cells give them a black color, while polycrystalline cells are blue. Both solar panel types have long lifespans, and their payback is less than 5 years in most cases. Solar manufacturers normally offer a 25-year power production warranty, but some brands go as much as 30 years. So, do you want a specific color? You can get black or you can get blue if that's what they want. You can give them either one, but just know the black ones are the mono and they're more efficient. So you may find polycrystalline panels to produce 300 watts. So let's say that here's how the actual difference comes into effect. If you have a polycrystalline panel that produces 300 watts, an equally sized monocrystalline panel will actually produce 350 watts. So for kilowatt hour production, let's say we have space for 20 panels. You'll get 7 kilowatt system with the monocrystalline panel, but you're only going to get a 6 kilowatt system with the polycrystalline panel. As a result, mono panels are slightly more efficient than poly panels. They also perform better in the heat and in lower light environments, which means they will produce closer to the rated output than in less than ideal conditions. So we're not using 350 watts. This is just an example, right? But if we have 20 polys and 20 monos, 20 polys would probably be about a 300 watt panel. That would be a 6 kilowatt system. And if we swap those out for the mono panels, the same size panel, it's 350 watts per panel, not just 300. So it's actually a 7 kilowatt system, which means it's going to produce more kilowatt hours, which is what the customer needs. Has this been going over anybody's head? Anybody need me to repeat anything or clarify anything on this? It's okay if you do. If you do, that means somebody else does. Don't be afraid to ask. Cool. So here's a little bit about our equipment. So the Hanwha Q-Peak, we're using the G10 for 400 watt panels. Breakthrough efficiency is 21.1%. The Q-Cell is the first module manufacturer to pass the most comprehensive quality program in the industry. And the new controlled PV of an independent certificate issued by that place, TÜV Rheinland, something like that. I don't know, German. All weather conditions. It'll work in the snow. It works in low light. It works in temperature behaviors, whether it's higher or lower. They're great equipment. Enduring high performance, so long-term yield security with anti-LID technology, hotspot protection, and traceable quality TRAQA. So it's just one of the actual products that are in with equipment with Q-Cell. Okay. Extreme weather ratings, high-tech aluminum Li frame, certified for high snow and wind loads, up to 150 miles per hour on wind loads. And the warranty is a 25-year linear performance warranty and a 25-year product warranty. So this is the info on the Q cells, the 400 watt that you guys need to know about for our equipment. I'm going to let Hanwha explain a little bit to you, and I'm going to have we're going to talk about racking and the type of racking that we use. Okay. Anybody else need a few more minutes to write this down? Any of this stuff down? You guys want to screen grab it later? No? Okay.
We do this with
Okay, so that's some of the specs. That video will be available for you guys to go back and rewatch multiple times. But just take out of it. What we take out of that is this, okay? 20% higher efficiencies. You guys can see basically in the video the difference between standard solar panels and what Q-Cell has to offer. Just out of curiosity, were you guys able to hear the audio? Yeah, okay, cool. Because the next one, the guy's gonna be talking, so it's actually for our racking systems. But they're awesome in high heat and low temperatures and snow. They're awesome just across the board, which is why we use these. And the cool part is they're monocrystalline panels. So when we're looking at equipment types and customers are trying to compare us apples to apples with other companies, well, they're probably going to be using standard equipment of RECs for some of these smaller companies. And we're going to still be beating them in price. Why? Because we don't go to distributors. We go directly to manufacturers so we can get the same pricing that distributors get. Then they charge their upsell price for because they're buying containers. Well, Titan buys so many of these things directly from them, they're actually white labeled. So when you see a Titan solar power panel, it's going to be the Hongwen Q-Cell. Okay. So that's the cool part about it. So you know exactly what you're looking at. So if the customer does want to compare it, you guys can show them these videos and you guys have this information about how they compare it to some of these other panels. And we always have spec sheets that are available in your guys' document libraries as well. Okay. Well, so here, we're going to talk about our actual racking system. So this is directly from Everest. I just put this slide together. That's why it still says QPeak Duo, but it's actually, we're going to be talking about the Everest K2 mounting system. Give you guys a little bit of understanding about how the mounting works. It's not the most exciting video in the world, but he talks about all the warranties and all that good stuff inside of this video. It's about 8 minutes long. I'll let you guys watch it. When we come back, we're gonna finish up this, the cell module, and then we're gonna take a 25-minute break, okay? Here we go.
We do this with all of our products. So our first is our traditional Crossrail system. This is the platform for our systems. It's like it's your dual rail installation. Then we have our shared rail system, which is going to use the same components as the Crossrail with two innovative components such as the clamps and the slider. Last, we have the Crossrail tilt-up, which also is going to use the same components, but has two different innovative components that are the tilt-up connector and the climber. Here we have our rail profiles. We have the Crossrail 48X, which is optimized for low snow loads and low wind loads, such as regions like here in California. And then we have our Crossrail 48, which is stronger than the 48X, and this is designed for regions such as Nebraska, Colorado, or somewhere in the Midwest. And then lastly, we have our Crossrail 80, which is optimized for heavy snow loads, heavy wind loads, like places in Hawaii or even in the East Coast. Both or all three of our rail profiles come in mill and dark anodization, and they also come with integrated wire management, which is going to help you guys reduce the expense of zip ties or any clips. You can easily hide your wires through our integrated wire management that comes with our rail profiles. Here we have our structural splice. Our structural splices are UL 2703 listed with bonding integration. Very easy to install. All you need is 2 T-bolts and 2 nuts. This is our splice is really easy to install because we've actually seen a lot of customers and a lot of installers assemble this on the ground, put their splice with their rails, and then easily take it up to their roof. This is going to help you guys' time by making sure that you guys aren't up on the roof, messing around with the splice, trying to put together the splice on the roof. It's a lot easier and will reduce your time as well. So I just want to touch on our structural splice and the benefits of our splice compared to the competitors out there on the market. So here's an example of a 3x10 array in portrait using a non-structural splice. So say we're doing an installation in San Diego with 110 mile/hour wind speeds. If you use a non-structural splice on this array, it's going to require for you to add 2 attachments per splice. So as you can see here, the dots are the attachments, the orange is the splice, and then the blue lines is your rails. So for this array, it's going to require for you to add 48 roof attachments, which is pretty excessive. Now, if you use a structural splice, on the other hand, which we provide here at Everest Solar Systems, this is going to reduce the number of attachments that you're going to need for your array. So on this array, you're actually only going to need 36 compared to the 48 that you would if you were using a non-structural. So how does this work, you might ask? Our structural splice creates a continuous rail beam through your rail run. So there is a bonding connection throughout your whole run. So this is going to allow you to reduce the amount of attachments that you need for your roof. So you see here on our splice, which is the thick red line, you're actually going to need 1 attachment per your splice. Another benefit that comes with our splice is it eliminates the extra attachment that you're going to need for your cantilever. So say, for example, you're on the roof, you're installing your array, and when you're about to end and finish, you realize that you don't have enough rail to add your last panel on there. Well, with our splice, you can actually just connect the splice, add a little bit of extra rail on there, and then throw your module on there without having to add extra attachments. So we've actually heard from customers that this makes it a lot easier and reduces the time of installation by not having to add so many attachments to your roof. So this is a perfect example on how this is going to reduce the time of installation. It's going to reduce you having to install so many attachments and help you by making sure that your rail runs is easily installed with our structural splice. Here are two of our clamps. We have the mid clamp and then we have our end clamp, both in dark finished look. Both of our clamps come pre-assembled for easy installation. Also come assembled with our spring loaded spring, which makes it easy for you to hold, and also it doesn't require so many hands to install. You just simply pinch the MK3, which is a slot nut at the very bottom, and then engage it into the roof, turn it clockwise, and bam, you're golden. It's installed. A lot of our customers love our clamps because of the easy installation. And another benefit is that it's truly universal. You don't have to stock multiple different clamps for different sizes of modules. Our universal clamp comes to fit 30 to 47 millimeter modules. Here we have the MK3 slot nut that I was actually just talking about. This is used for a lot of our components here at Everest Solar Systems. It's what connects the component to the rail and creates a bonding connection through the system. We also have multiple different aesthetics to add to our arrays to make it nice, clean, and beautiful to look at. We have a rail sleeve, which you would slap onto any mill rail to make it look like it's a dark finish, which is nice and appealing to the end customer. And then we also have end caps to hide all of the wires that are inside of the rail. Now, here are our two roof attachment options. First, we have our Everflash Q-Comp kit that comes with the Quick Mount Elevated Water Seal technology, which is a little flute that's added onto this flashing to prevent any water intrusion from coming in. Then we have our Everflash E-Comp kit with the EcoFasten Solar Watertight technology. Also comes with the patent channel design to prevent any water from coming in. And both of our Everflash kits come kitted with the L-foot and the lag bolt as well. Here are our two tile roof attachment options. We have the single hook, which comes with an elevated lip, so you don't need an L-foot to attach to the rail. Comes also with 5.5 inches of adjustability. And then we have the 3S tile hook, which also comes with adjustability as well. These are two options that have been selling a lot here in California, where there's multiple different homes with tile that is needed. Here we have the evolution of the cross rail. So earlier I was talking to you about the shared rail system. This shared rail system is going to reduce the amount of rails that you use and also reduce the amount of attachments that you're going to use as well for this project. Traditionally, you need 2 rails underneath your run to install, but with our shared rail system, you actually can share a rail for both rows of your array. By using our innovated clamp, you can just go ahead and lay down the module on top of the clamp and it'll just sit comfortably there. This shared rail system is something that we've actually just launched into the market, and it has just been spreading like a wildfire. This system is going to reduce your amount of installation and also reduce the cost of your installation as well. By reducing the attachments and reducing the rail, it's going to be easy to install, and it's going to be a lot faster to install as well. We have our Crossrail tilt-up system, which is our tilt-up system that utilizes our Crossrail, and it comes in 7, 10, and 15 degree tilts. The really neat thing about this solution is that you don't need an extra component to create your pitch for your array. You simply use the same Crossrail that you use for our other solutions. You just can cut it to whatever degree you want to give you that nice and finished look. You actually need a tilt-up connector as well to connect the back leg to the front leg. It just requires 3 T-bolts, and then we have a climber set as well that is used to connect to the front leg and connect to the horizontal leg as well. It engages to both the rails and gives you that connection. Both of these solutions are found on our website, so if you would like more information about this, you can find it. You can find assembly instructions and engineering letters on the website as well. And this is an example of how to create your ground. All of our systems are integrated bonding through our clamps, and you can also purchase our grounding lugs as well, which is this weeb lug right here that connects to the end of the array, and you just attach your copper wire and boom, you got your grounding.
All right, sorry about that. I was finishing up a call. All right, so yeah, guys, I'm helping out the team right now. Gabriel just got, don't know what size system it is. I think it's 8 kilowatt system, but Gabriel just got an 8 kilowatt system right now while you guys were watching this video. So that's what took me so long to get back. Sorry about that. But yeah, any other questions for me on this stuff before we take a break? I have, everybody's going. Cool. Yeah, go ahead and take a break. Let's do, it's 45 past right now, so it's 4:45 my time. Let's come back in 30 minutes at 5:15 my time. All right. See you then. What's up, guys? All right. Everybody's back on. Let's do this. Let's have some.
Not beer. I know what beer smells like, but it wasn't that. And she was.
All right. Now, let's go ahead and get back to the training. So let's go back to this last slide over here with the racking. So give you guys a little bit of background on the racking and why I wanted to tell you, why I wanted you guys to watch that super boring video. Because yes, I know it is extremely boring, but it's important because this is the type of stuff that's taken into consideration when the install side of the company is they're determining on what they're going to be using, right? So there's a lot of great things about the Everest, which is why it's being used. Number one, you can go direct to deck. You can also go direct. You can also go to the truss. You have the really good seal proofing, great warranties. You have those fixtures in there, so you don't have to be zip tying wires. You can actually hide the wires. You have those end caps, which make it a nice cleaner install. So when you're doing the K2 system with the actual the triple black panel with the Hanwha Q cells, it's such a clean and smooth installation. You're not seeing part of the silver racking sticking out of the end. You're not seeing a ton of wires bundled up all over the place. It's a lot cleaner, a lot smoother design. Okay, a lot cleaner install too. So this is why we're using that equipment. So you take all that information, again, we take a lot of information, we boil it down. So when it comes up, when you're comparing installations and what they look like, this is why. Did everybody get a good understanding based off of what he was talking about with the install? Were you guys a little bit bored during it? That's okay. I was, and I've had to watch it like a dozen times. So, but it's good info. It's good stuff to know. We'll talk about how and what to say and when it's important to give this type of information, because just sales in general, too much information to a customer and they feel overwhelmed and they don't want to participate in the conversation any longer, right? So if you give somebody too much information, it creates an objection of I want to think about it. You give them too little of information and they feel like you don't know what you're talking about. So about finding that balance in between. And that's what we're going to be doing later this week. Today, I'm just going to overload your brains and then we're going to slowly unpack it during the rest of training. Okay. So you guys know, you guys will be getting out of here just a little bit early so you can go in there and update your digital business cards for the last half hour of what class would be. Did you get the new link? Did it work for you?
Not yet. I'm working on that right now.
Cool. Yeah, because I texted it over to you, so you should have access into that now. Okay. Should be working
you.
just fine for you now. So TitanSPP.com. If you guys haven't gone to create your digital business cards, TitanSPP.com. I'm gonna put it back in the chat. Okay. --sales--register. What you guys are going to do is first letter, your first name, your full last name. Tonight, you guys are going to be able to log in there, upload your profile pictures, put the company name in there, put your website, your link inside of there so people can see it. I'm going to show you guys how to do that. Okay? Any questions about what we've covered so far? I know that was a ton of information, but what kind of questions you guys have for me? No? Okay. Let's talk about inverters. This will be one of the last modules that we cover today. So we're going to go inverters, talk a little bit about the overview for solar, and then let you guys out and pick up tomorrow with solar storage. Okay. So inverters are a fun one. So we're going to watch a couple more videos. They aren't nearly as boring as the other ones, but we're going to watch from the actual companies that we use for the inverters, but we're going to learn about them first. Then we're going to do the same thing we did before. So there's a couple different types of inverters. We got string inverters and micro inverters, or independent and string. Okay, so I'll show you guys the difference between what a micro inverter and an optimized system is, but let's just compare the two major ones, which are string inverter and micro inverter systems. So solar inverters have one core function: to convert the direct current or DC solar panels generate to alternating current, which is the type of electricity used in your home. Okay, that's the main core function. String inverters. What is it? A string inverter, also called a central inverter, is a standalone box that is typically installed close to your main service panel and electricity meter. There's typically only one single inverter or possibly two string inverters on each residential solar system. It really depends on the overall solar system size. A string inverter functions in a series circuit with there usually being 6 to 12 individual solar panels in what is known as a series string. SMA is the leading manufacturer of string inverters. So let's learn a little bit about the string inverter, the pros, the cons, all that good stuff. The pros of a string inverter is that it's easy to troubleshoot. The main advantage of a string inverter is that you only need one of them in order to convert the DC electricity from coming from your solar array to AC power. If anything is going to fail in your solar system, it's likely going to be the inverter, making troubleshooting relatively easy when things go wrong. The cost is a lot less. So installing a single string inverter on a solar panel installation is cheaper than installing microinverters. Less labor hours are required, and string inverters are more affordable than microinverters. Lower probability of a wiring mishap. There are less connections between solar panels and a string inverter. Therefore, there's a reduced chance of a string inverter setup to be improperly cabled compared to what a microinverter system would be. So again, we're going to go overview and we're going to boil this down. Now, here's a con: compliance with rapid shutdown requirements. So if you live in an area, which all of us now live in areas that require rapidly shutdowning your system, additional labor and wiring will be required completed to shut down your system within compliance. A rapid shutdown box will be installed near the electrical service entrance, and control wires will be needed and routed between the string inverter and the electrical panel. Since there's electricity flowing from your panel with the string inverter itself, the inverter has to be disconnected from both these two different places. Since the cost of adding rapid shutdown requirements to your solar energy system is not negligible, it's important to check with your local codes or ask your installer what type of system would make most sense for you. So let's finish up with these cons and we're going to talk a little bit more about it. Now, a huge con: efficiency and partial shade. So we learned about partial shading, right? Since string inverters require solar panels to be wired in series, if one solar panel's output is affected, the entire series of solar panels is affected in equal measure. This can pose a major issue for some, or part of the solar panel series will be shaded by part of the day. And then more difficult system expansion. To get optimal performance from a string inverter, it needs to be working near peak capacity. So if you want to increase your system size of your solar array at some point down the road, these panels will need to be routed in separate string inverter, adding additional complexity and cost. So let me boil this stuff down for you guys. Okay. Now, oh yeah, there's more. Sorry. Shorter lifespan. String inverters usually last between 8 to 12 years, whereas microinverters have a 25-year warranty. System level monitoring is not possible. You cannot see what your panels are doing. You can see the aggregated production, so what's being converted, but you can't see how the panels are doing by themselves. So if there's a crack or debris or some type of defect in the equipment, you can't tell at the actual panel itself. So let's talk about the actual solar string inverter itself. So one of the biggest cons is, and this is the biggest thing for customers to understand when we're talking about string inverter systems, and I actually draw this out for my customers. I'm gonna draw a little happy house just like this. So, and I'm gonna pose a question. What happens if one of the panels gets shaded? Well, it works a lot like a Christmas light. What happened to Christmas lights? When one of the bulbs go out, the entire array is gonna go out. That whole string goes out, which means that if one of them gets shaded, instead of that one panel reducing efficiency by 30 to 40%, the entire array is going to be shaded by 30 to 40%, just because that one little panel right there is being shaded. So the rest of the array works just like that. So if you have a 40 panel system and 20 of them is in one of the arrays, you're going to have 50% of your system is going to drop production by 30 to 40%. That's a huge number. And it's a big problem for most people when they're trying to size their systems out. So what happens if just one of them stops working completely? If there's an issue with the actual panel, there's a defect. Well, it works the exact same way as well. If one of the panels goes out, the entire array stops working. So it's a total array outage. It's not something that we want to have. So string inverters are often referred to as and they're compared to Christmas lights. So think about the old school Christmas lights. We've all dealt with that situation. If one of the bulbs goes out, the entire series is out and you have to play hunt and peck. They have to do the same thing with a string inverter installation. So it creates a little bit of an issue, creates a huge issue for the customer because you can't see if there's a problem with the actual panel itself, that it's shaded or there's an issue. It's just a drop in production. You don't know why. It could be one of the panels is bad, one of the panels is being shaded. There's a lot of issues that can't be tracked with the string inverter system. So what about microinverters? What's the difference? So microinverters perform the same basic function as string inverters, except they're installed underneath each solar panel on your roof. Each of these microinverters is about the same size as an internet router. The big difference between the microinverters and string inverters is that the solar panel installation with microinverters will typically have the same number of microinverters as they do solar panels. So they go directly on the back of the actual panel themselves. So you have a bunch of different microinverters on every single panel. Okay. They convert the power directly at the panel, then transfer it down to the utility box so that it can, because the power is already AC by the time it gets to the breaker panel, to your utility box. Okay. So nothing's being done down here compared to what it is on the string inverters. So we're going to hear a little bit about from Enphase, who is our microinverter supplier. Hear what they have to say a little bit about it. We do offer Enphase, not our favorite, but we're going to talk about who our favorite is here in a little bit.
Solar panels may get the glory, but it's the inverter that does all the work in a solar PV system. Tucked beneath each solar panel, microinverters are responsible for converting the direct current produced by your solar panels into alternating current your home can use. With such an important role in safety, efficiency, and reliability, it's no wonder homeowners insist on using Enphase microinverters. Enphase is the world's leading supplier of solar microinverters with 940,000 Enphase systems deployed to more than 110 countries. The newest advancement in inverter technology, the Enphase IQ7 microinverter, is a powerhouse. It is available in multiple configurations, engineered to meet the needs of residential and commercial systems. Don't let the lighter and more discreet form factor fool you. With the IQ7 microinverter series, you get consistent high-power production, even when panels are shaded or soiled. That's not all. The Enphase microinverter burst mode helps produce energy even at sunrise and sunset. Now that's powerful. The IQ7 microinverter is proven safe and reliable thanks to more than 1 million hours of testing and an all-AC design that eliminates dangerous high-voltage DC on your roof. And in the event the grid fails or spikes, the IQ7 microinverter allows for rapid shutdown to prevent your solar PV system from energizing the grid and risking the safety of others. The advanced performance found in an Enphase IQ7 microinverter can even help with aesthetics. By producing more power, you can choose to install less panels, which can provide a more discreet rooftop installation. It is also easier for your solar installer to install and maintain. Are you looking for a complete home energy solution, including battery storage? That's not a problem with the Enphase IQ7 microinverter. The modular and flexible architecture of the Enphase IQ7 microinverter has been designed to support system expansion and storage solutions available today and in the future. Choosing the best inverter technology is one of the most critical decisions to make when going solar. By choosing Enphase, you be assured that you've made the right choice.
So there's a little bit about the microinverters. So let's talk about them in depth now. Okay. So the pros to the microinverter system is they do comply with the rapid shutdown capability. So it does have that capability. New electrical codes require rapid shutdown for first responders or firefighters to make sure that they're safe from high voltage when they need to be on rooftops or servicing power lines. Microinverters comply with these rapid shutdown requirements and have the capability embedded in each of the modules themselves. You essentially get more electricity. So the core advantage of using microinverters is that theoretically you can yield more solar electricity. The reason for that being is that there's slightly difference between currents in each of the panels, right? They could be shaded, there could be a defect or a problem. So when solar panels are in a string, the current is reduced by the least producing panel in the string. So if you have 10 panels, the first 5 are operating just fine, then number 6 is causing a problem, then only the amount of power that's being sent through 6 is what's going to be in the rest of the system itself. With microinverters, you don't have that problem. Every panel works independently. So we like to say there's independent systems and there's string systems when we start having these conversations with the customer, because yeah, these can be pretty great systems. There's suitability for changing installation conditions. So if you have multiple angles or facing or multiple azimuths is going to be the best example. So south, east, west, north, the microinverters will be the way to go. Or if you have some type of shading issues, because you can put them on multiple azimuths and still not have to worry about them being tied up into that string. In these situations, the solar panels will be producing different amounts of electricity at different times of the day, but microinverters will ensure you harvest all the energy. While with your standard inverter, you'll lose some of its production because of the shading, because of the defects, because of whatever the case may be. Okay, so think about it. If you have multiple arrays, so let's say we split the system from east and west from 9270, right? It's like during the first half of the day, if it's a string inverter system, it's like, oh, during the first half of the day, you're going to be collecting all this power. Now you're not going to get direct sunlight on the other side, on the other panels, but you're still going to be producing some of the power. On the other half of the day, that's going to flip flop. You're going to get indirect sunlight on the east facing panels, but you're going to get the west facing panels producing all the direct sunlight. Well, the issue with that is that now in a string system, they're probably tied together, which means that they're still only going to be operating based off what the lowest producing panel is. With microinverters, each panel works independently, so that's not going to be causing any type of an issue. So if one panel goes out, only that one panel is affected. They do have a longer lifespan. Microinverters typically have 25 years warranties, while standard inverters only have 8 to 12-year warranties. The reliability of microinverters was in question several years ago, but the technology has since caught up with itself in the industry, and longer warranties show confidence that manufacturers have in their product. All right. Panel level monitoring. You can see what each panel is doing individually and what the production is. You can track it by the actual panel itself. And then if you want if you want to add extra panels to the system down the road, you can just pop on a new inverter onto the back of the panel and land the panel. So it's easy to be able to add additional panels down the road. Okay. Now for some of the cons, okay, the costs, they are expensive. Microinverter are expensive. They're typically $1,000 more expensive than a string inverter on a standard 5 kilowatt system. The larger the system, the more expensive it is. I've seen it up to $4,000 more expensive to go with microinverters than with the string inverter. The maintenance is not great. So if one of the microinverters were to fail, not only would be detecting which one of these would be a challenge, but once you did, servicing and replacing the component is not easy as popping off a new string inverter on the side of the house and then putting on a new one. Okay. We have to get up on the roof again. We have to test everything, reestablish the AC connection, and make sure that it wasn't an issue with wiring and that it was an actual issue with the actual inverter itself. The amount of hardware on the roof. So this is crucial. This is actually one of the main reasons why we don't like them. Since the microinverter attached to every solar panel on your roof, there are a lot of expensive metal equipment up there. Microinverters can act as a miniature lightning rod. So if you're in a storm-prone area, you may not want to be looking at these type of things. Now, just overall, because of the cost, because of the maintenance, because they do have a tendency to go out a lot, even today, we still see a lot of microinverters failing pretty consistently. It's not something that we use as a standard. Okay, they're very expensive for sometimes very ineffective equipment, which is unfortunate. They have pretty cool ideas. Some of them work very, very well. It's just not our favorite equipment. So let's talk a little bit about power optimizers and what the difference is. Okay, so if you take a look, it looks a lot like the other one where we have an inverter, then we have a service panel. There's going to be a shutoff switch there, and then we have the breaker. Okay, but we still have these little things on the back. What is that? So microinverters convert DC energy to AC energy right at the panel. While power optimizers are also located on the back of the panel, they don't convert the electricity on their own. Instead, optimizers condition the DC energy and they send it to the central inverter to finish converting the AC energy over there. Okay, so all these do is it makes it so that they work independently, just like a microinverter system. A microinverter gives you much more flexibility with your system design. You can build your array in a partially shaded area or split strings across the usable space on your roof. Optimizers ensure you get the most production out of each panel in your system. So it helps do the exact same thing. So you get all the benefits of the string inverter system with additional benefits from the actual microinverter system, because now you're conditioning power, you're not converting it at the roof. So microinverters and power optimizers are comparable technologies, so comparable that some companies would describe them as interchangeable. We never would. They are not interchangeable. Both are collectively referred to as module level power electronics, or MLPEs. But they are not, but there are important differences between these setups that make them either more or less suitable for the installation. So on all of our territories, these are the best forms of installation, best for installation. It's actually our favorite inverter to use because we have the best of both worlds. So here's a video from SolarEdge that actually explains the pros and cons to all of them.
A photovoltaic
and why we
system
use it.
consists of PV panels, which produce DC power when exposed to sunlight, and an inverter, which inverts the DC power into AC power that is fed into the utility grid. 3 different inverter topologies are currently used in PV systems: a traditional string inverter system, a microinverter system, and the SolarEdge solution. The traditional string inverter topology, which is still used in the vast majority of all installations, has a number of significant drawbacks. In traditional systems, panels are wired in a series as a string. Since each panel has a unique power production profile, which is a function of differences in manufacturing variances, installation parameters, and shading patterns, the entire system's output is limited. The traditional system design requires all strings to be at the same length, using the same type of panels, and to be positioned at the same angle towards the sun. Real-life installation constraints result in either wasted roof space or unnecessary duplication of system components. The DC cables which connect the panels to a string carry high voltage as long as the sun is shining. The traditional inverter cannot shut down the panel's DC voltage, and therefore poses serious risks to installers and firefighters. A traditional system cannot track power output, temperature, or any other parameter of a single panel. This makes it impossible to identify specific panel-level problems remotely. In the 90s, another inverter topology was introduced: the microinverter. This topology takes the functionality of the traditional string inverter and scales it down to fit a single panel. By controlling each panel individually, microinverters are able to solve certain challenges of the traditional system. However, microinverters have their own inherent drawbacks. This topology requires each panel to have its own microinverter with full inverter functionality. Therefore, it has significantly higher upfront costs relative to traditional inverter topology. When we started to develop the SolarEdge solution, we defined 3 goals: to optimize power generation of each panel individually, to use the same installation methods and components used to install traditional inverter systems, and to compete with the cost of such systems. Eventually, we developed a topology that meets all of these goals. The SolarEdge DC optimized inverter topology combines the best of both worlds. Our solution splits the traditional inverter functionality into 2 products: the Power Optimizer and a simplified inverter. The Power Optimizers are located on each panel, turning the panels into intelligent panels. These Power Optimizers provide panel-level tracking and real-time adjustments of current and voltage to the optimal working point of each individual panel. The simplified inverter is installed similarly to a traditional inverter, but it is only responsible for DC-AC inversion and grid connection. Our solution includes 2 additional features: a panel-level cloud-based monitoring platform, which is accessible from any computer or handheld device, and an enhanced safety mechanism. When installers install the SolarEdge solution, they use the same cables, connectors, and methods as used in traditional systems, and are able to install more panels to combine long strings with short strings and to install panels on different facets of the roof. The SolarEdge cloud-based monitoring platform provides full data at the panel, string, inverter, and system level. This allows for immediate fault detection, real-time alerts, and comprehensive analysis. These important features reduce operation and maintenance costs. In addition, we have incorporated panel-level safety mechanisms to protect installers, electricians, and firefighters. With the SolarEdge solution, whenever AC power is off, the string's DC high voltage is automatically reduced to a safe voltage. This solution meets new safety regulations in all significant PV markets around the world, as well as the 2014 National Electric Code in the US.
All right. So can everybody see kind of why that's our favorite inverter to use? You get the best of both worlds on that thing, and that's why we use them. It's a standard. Now, if a customer does want the in-phase, we can use the in-phase, but our standard and our go-to is the SolarEdge. It's got 99% efficiency rating. It does only have a 10-year warranty, but with us, they get a 25-year warranty on that inverter. So we go ahead and extend that out at no additional charge to all of our customers. So who has questions for me right now? Awesome. So talk a little bit about the system sizing. So again, this isn't something that you guys are going to ever do in your job. This is what we do on the back end. We have our programs and all the stuff that build this stuff out, but I want to give you guys a general understanding about how we do this stuff so that you know how we're coming up with these offsets and you guys can see in real time how this stuff can actually affect the system's actual installation. Okay, because there's actually a lot of algorithms and math that go into this. So system sizing, to try to figure out the size of your solar system, you take the kilowatt hour energy requirement and divide it by your peak sun hours to get the kilowatt hour output. Then you divide the kilowatt output by your panel's efficiency to get the estimated number of solar panels you'll need for your system. So if you take a look at this usage right here, you can see they use a lot of power during the summer months, right? Most utility bills look exactly like this. So when we're looking at a lot of bills just like this, like, okay, cool. We need to produce a lot more power here during the summer months. This is where they're going to start getting a lot of their bill credits. We have to size the system throughout the entire year for an average, but we need to work on the azimuth and the tilt and all these other things to be able to make sure that we're sizing the system appropriately. So we have to do something similar to this. So here's how we actually size our systems bound on the back end through our apps, but it's the same core function. So the formula is this. You get the annual kilowatt hours, you divide it by the peak sun hours. So that's going to give us the system size. So let's say we have a customer that's 14,500 kilowatt hours. Well, we're going to determine based off the tilt, the azimuth, all these factors, the shading factors, the peak sunlight hours, all that is going to be affected. All that's going to affect the peak sunlight hours. So in this case, the factor is going to be 1.7, which means that we need 8,529 watts in order to be able to, that's going to be the appropriate system size to get 100% of what the customer needs for their output for 14,500 kilowatt hours. Well, let's figure out how many panels that is. So system sizing, we take the system size at 8,529 or 8.52 kilowatts, right? So 8,529 watts, and we divide it by the panel wattage, is going to give us the number of panels. So let's do that. It's going to be 24.116 panels. Now, can we start chopping away fractions of panels to be able to get that 0.116? No. So do you think we round up or we round down? Up, exactly. So we're going to go ahead and round up. So you round up the number of panels and you times that by the panel wattage, right? So if we have 350 watt panels, that's going to give us an 8.75 kilowatt system or 8,750 watt system. Now we start looking at the offset. So what's this going to be offsetting their utility? Well, if we just added that one extra panel, so we're going to get the system size times the peak sunlight hours. That's going to give us the produced kilowatt hours, and then you divide that by the required, which is what they needed, which was the 14,500. That's going to give us our offset. So our system size is 8,750 watts or 8.75 kilowatts times the 1.7. So we're working backwards. That's going to give us 14,875 kilowatt hours. They need 14,500 kilowatt hours, which means that if we divide the 14,875 by 1450, we're at 102% offset. We're going to produce 2% more power than the customer used over the last 12 months. So they have a little bit of wiggle room. Most utility companies will buy back up to 110%, and we'll go into more detail about this later in the week, 110% of the customer's usage for the year, for the last 12 months. Some utility companies go up to 120%. Those are typically co-ops and some of the very, very large utility companies. We're looking at average across the board is 110%. So we usually build it somewhere between 100 to 110% to give them a little bit of wiggle room. So this is what an actual proposal looks like for a customer. So in this case, we're looking at somebody who has a $245 a month electric bill. Now, there's a 4% annual escalator on all utility bills. All of them. Across the board, nationwide, bills are going to go up. Are we all familiar with inflation? Yeah, look at gas, right? So if they use the same amount of electricity in the next 25 years that they used over this last 12 months, their bill is going to go up by over $400. So it's going to be $653 a year average a month average that they're going to be spending on utility in 25 years. That's $2,942 a year up, and then it goes up to $7,842. That's $122,000 by not going solar. So you're going to spend $122,000 on electricity. So what's happening with solar? Well, what's happening is that you're now no longer renting your power. So actually putting a cut date. Same reason why you bought a house versus renting your house. So right now you're renting utility for for your entire life. But all we're going to do is we're going to condense that, put that in 25 years, and then look at saving you some money. So a lot of green involved in it. So there's an equivalent of 322 trees are going to be planted. Over 9 tons of carbon offsets are going to be taken care of. But take a look at the property value increase. So it's estimated for this house to increase the property value by $39,040 to that customer. That's a huge amount of savings right there for the customer. Well, how does it actually look for their system? It's a great question. So this was a new build. So we did a lot of sizing, got a lot of information to make sure that we're projecting out the system correctly. With this customer, this is what their roof design would look like. Okay. So we got the plot lines and the designs from the actual builder themselves. And then we had our proposal writers plot them out and put the panels where they would actually fit. This is going to be an 12.8 kilowatt system. They're going to produce 20,026 kilowatt hours their very first year. This is 32 400 watt Titan solar panels. And it's going to be right now, it's looking at 2 different inverters. I would just max this out and just put the 10,000 inverter, the 10,000 AC inverter rather than 2 different inverters, especially because in TEP, it only allows a 10,000 watt inverter. But how does that come out for the customer? Well, let's look at their actual usage. So here in the orange is where they're going to be creating all that excess power. Okay, this is going to be their bill credit area. This is their safe zone. Okay, here is where they use any additional bill credit that was saved up. Now, does that mean they're always going to have zero bill? No, we don't control what they do in the house, and we can't control the sun, right? So we're planning, this is the base case scenario, to produce 8% more power than what they actually use over the last 12 months to give them a little bit of wiggle room. They can lower the AC, be a little bit more comfortable. They can get their electric car, something that's going to help them, something that they've been wanting to do. We could even build this higher than that if they are planning on making those type of additions to the home. So their average electric bill is $245. Their first 18 payments are only going to be $87 a month. Now, their new utility bill, if they decided that they, let's say they overuse and they get an overcharge, their new utility bill average is only going to be $43 a month. Okay. How does this work? Very simply, just like this. So we're using a GoodLeap 25-year 1.98 flex pay. Their first 18 payments are interest-only payments at $87 a month. If they reinvest their federal and their state tax credits, their payments are only going to be $169 a month. That's all they're going to pay locked in for solar. This payment will never increase. Why is that? Well, if they don't reinvest it, it's your money. Decide what you want to do with it. If they don't reinvest this, they don't have to, but now they're going to be financing the full 52,000 term. Okay. If they reinvest it, their total net system cost is only going to be $38,189. That's it. So on payment 18, what's going to happen is they're going to re-amortize the loan, which is essentially like a free in-house refinance, right? They're going to do it automatically. They give you 18 months to put a down payment towards your system for your federal taxes and for your state tax credit, because you can't file your taxes tomorrow. So they're going to assume you go ahead and put it in there. So they're going to give you a very low payment to start out with, so you're comfortable. If you reinvest that tax credit within those 18 months, your payment's only going to be at $169. It's never going to increase. That's the beauty of the tax credit and how our financing works with the FlexPay. Now let's take a look at the process. It'll show them the process, which is the savings report, which is what we just did, the approval process. All we do is we click on this box right here, and it'll pop up the credit app with the last four of the social. It's a soft credit pull. We do not use a hard credit pull in order to be able to determine whether or not they qualify for solar. And then we get the document signed. It goes to site survey. Then we do our permitting. We have to get the CAD program, submit them for permits, talk to the utility companies, and then they get installed, and then we can activate the system after final inspection. And it has a recap form on the final page. Okay. So that's what a proposal looks like. And we use all those factors. So if we take a look at this one right here, we have a mixed azimuth. So we have looks like 175 degrees south, right? Maybe 170 on the azimuth. And we're looking at probably 80 and 260. So we have a mixed array. So this is why it's going to be really great to use a solar edge, because now if one of these panels go out, does the rest of them get affected? Nope. If one of them gets shaded, are the rest affected? Nope. Do we have to worry about fires or lightning storms or anything like that with this type of a system? Nope. And they get a 25-year workmanship warranty, a 25-year equipment warranty, including the actual inverter, which we extended out for them from 10 years to 25 years. Okay. Yeah, so tomorrow we're going to go over the breaker boxes and stuff like that. I do want to talk about, there's the K2 video. So let's talk about why a lot of homeowners go solar. So let's, and then I'll let Brian pick the rest of that stuff up tomorrow. So why do homeowners go solar if they're planning on selling their house? Great question. I can answer that for you. So it does increase the property values. We just saw that one was going to increase it by $1,000 more than what they spent on the total system cost. Homes with purchased solar sell up to 20% faster. It's a great value proposition. It looks better on the MLS, so realtors it makes it easier for them to find it, because there's a huge search criteria that you can put in just for solar. It handles the affordability option for the realtor. So if a realtor is touring the house with somebody that you're trying to sell, and they, oh, well, I don't know if I can afford the electricity in this house. Oh, it comes with solar, so it's actually going to drop that. And it creates urgency because they do sell to 50% faster than homes without solar. You're going to get more bids on the house a lot quicker. So according to a recent Zillow report, homes with solar panels sell on average for 4.1% more than comparable homes without solar across the United States. A study conducted by the Lawrence Livermore Berkeley Lab also found that homes with solar panels tend to sell faster than homes without. It's up to 50% faster than homes without solar. A consumer guide from the U.S. Department of Energy states that a solar electric system raises a property's home value by $20 for every $1 in utility savings every single year. It's a huge number. This is how we put those factors in. Now, we're going to talk about we'll go over 3-day right decision tomorrow. So here's a copy of the definitions. These will be available for you guys to download tomorrow. Okay. I just want to show them to you real quick. So a watt, what is a watt? It's a unit of electrical measurement. A kilowatt is a watt times 1,000. Kilowatt hour, kWh, is kilowatts. It's the unit of energy, right? When you guys see PPK, you're seeing price per kilowatt. If you see PPW, price per watt. PV system, very simple. When you see the word PV, it's referring to photovoltaic, which is just the scientific term for the solar system. When you look at any of the solar contracts, they all say PV. It just means solar. The tilt is the degree the panels are angled. 20 degrees is the standard for most of our territories. We may go different depending on where you're at, and that'll be done automatically inside of your proposal. You don't have to determine that yourself. The pitch, it's the customer's roof, 412, up to 12, up to 1012, right? We install up to 812. 412 is the standard. 112 is considered flat. 212 is nearly flat. Azimuth, the direction the panels are facing. Due south is best for solar. Offset, the amount of solar replacing last year's electricity utility usage. System loss, the amount of production the system will lose over time. Degradation rate, the rate the system will lose production. The example is about 0.5% a year. Okay, 0.6 to 0.5 to 0.6. Open mount versus fixed mount. It's the type of racking that's being used. Open mount, we're going to tilt the panels no matter what, but it's going to have about a 3-foot space in between each racking system. Modules, just another name for the panels. The terms monocrystalline and polycrystalline are the type of panels. String inverters run in series. If one panel stops working, the entire array stops working. Optimized and independent systems. Panels work independently. They do not affect each other. The rest of the definitions, typical solar warranties are about 25 years. Typical inverter warranties are 10 years. Typical workmanship warranties are 10 to 20 years. Typical battery warranties are 10 years. Typical system lifespan is 25 to 30 years. Solar financing is 5 to 25 years from 1.1% to 5% APR. Now, leases, we haven't talked much about this. We'll talk more about it later because we just don't like them. We don't really offer them. But a lease is typically a 20-year lease with a 1.9 to a 3.9% annual escalator. The inverter converts direct current to alternating current or sun power to house power. Power generated is sold back to the utility company's bill credit. Bill credit expires. It does not roll over year to year, only month to month. And if there's a battery backup, the battery is used before utility power is needed. Utility sells the power to the home as needed only for demand time of use. Okay, so when you have solar, they're selling you the time of use charges for when you do overuse. And the position, including the angle of the panels, they do directly affect the production. Now, this is just that recap for typical, just overall how solar works. We're talking about us, our warranties, our workmanship warranty is 25 years. Our inverter warranty is 25 years. Our panel warranty is 25 years. Typical lifespan of the Hanwha Q-Cell panels is 30 to 40 years. So for less money, they're getting better equipment, better, cleaner installs, and a better warranty. And that'll be it for today. What I'm going to have you guys do next is super simple. You're going to go back into your Sunbase, or not your Sunbase, sorry. You can go back into your digital business card. Okay, everybody should have been approved at this point. You're going to log in with your username and password that you chose. You're going to upload a profile picture. That way they can start working on badges. So after you pass your certification, they can send those out to you with your certs. Okay, it's going to be forward facing, no hats, no sunglasses, no crazy faces, no weird signs. This is going on your badge and on your digital business card. Customers need to be able to see it. Okay. So just get your face. We'll take care of the rest. That is your only homework. Now it's going to require you guys to put your website in there. Your website is titanspp.com/user/your username. If you scroll to the top of your page, when you open up your when you open up your digital business card, it's up there. Just copy paste it. If you're already in the edit, take out the edit part of it, right? So before you click edit, just copy paste that URL so that you can put it inside of the the website portion. Okay. So I'm gonna show you guys how to do that. Go here. When you go to the website, you'll see this. You can log in. You guys have less of this stuff, but what you're going to click on is my profile. It's going to look just like this. It's going to bring it to you every single time. We have new videos that we're putting up that shows the certification status is active. Matter of fact, why don't I just go ahead and grab that right now for you? So you guys can see it. So when we put it on, so when I click edit, so you see how mine is titanspp.com/user/Chris. If I highlight that, it's right there. I can copy paste it. You guys cannot upload anything. You can put your own YouTube video there if you want to. I'm gonna click edit profile. When you're certified, you'll get your YouTube and you'll get your certification seal. Titan Solar Power is the name of the company you work for, the phone number you would like your customers to call you at, and you have your website, which is directly right here. We see how it says action equals edit. If you delete that and just copy paste it right there. If you want your Facebook page, you can put it there, Twitter page, LinkedIn, your YouTube link, you can put it all right there, your WhatsApp number. I want this edited. You just click on this button right here so that you can upload, you can change your profile, you can upload a profile picture, just put a profile picture. Okay, super simple. So let me go ahead and grab one real quick. And there we go. Click the check mark. And you just edited your profile. Okay. All right. Super simple. So it's just under account, my profile. When you guys get your company emails, you can go down to edit privacy. And you guys can change to your company email tomorrow when you get those. Okay. But it has to go right there. That's it. That's all I need you guys to do for tonight. That is your guys' homework for tonight. Go into titanspp.com, log in, go to my profile, edit, upload your profile picture, put all your contact details in there, and we'll take care of the rest when you guys get certified. Okay. If your phone numbers and stuff like that change, you can always go back in there and you can make those adjustments yourself. You guys have full access and control of that. Cool. Anybody's brains feel like they're going to explode?
Un poquito.
Yeah. It's a lot of information in a short period of time. So now what we're going to do is we're going to start unpacking that information the rest of the week and putting it together with the actual sale and the proposal. Take a little bit of break from definitions tomorrow. You guys are going to do some training. Brian's going to start you guys out, talk about batteries, talk a little bit about our curve monitoring system, another freebie that we give our customers that other companies don't even offer. So you guys can see how cool that stuff is. We give it to our customers at no additional cost. So we're going to get that for you guys. And yeah, then I'll hop on and we'll start going over some appointment setting techniques and things like that. But yeah, 3:30 tomorrow, Brian will start us off and I'll finish us off. Any other questions for me?
No, thank you.
Thank you
That's
for
all.
joining me. I will see you guys mañana.
Thank you.
See you guys
See ya.
tomorrow.
Thank you.
Bye, guys.
Bye-bye.